Hey, hi. So in this video, we're gonna discuss one of the Leetcode medium problems, and this problem is a very good problem. And I feel that if you are learning about subarrays, then this problem you should definitely solve. So what this says is that you have been given an array and of repeated numbers, okay, and you have been given an integer k. So what that integer k signifies is, so given an integer k, you have to find the maximum length of the subarray in which frequency of each element, okay, frequency of each and every element is less than equal to k, okay, or at most k. So we understood the problem just here. Let's just try to shift to iPad screen, and let's write an approach or try to understand the problem firstly we will try to understand the problem in a more subtle manner, okay, in a more better way. So let's just shift to the screen. Yeah, so it is length of longest subarray with frequency less than equal to k, okay. So nums, suppose if it is given as 1 2 3 1 2 3 1 2, okay. Now let's just try to calculate the frequency one by one. Let's start from left. So 1 repeated one time, okay. So if I have a frequency here, so I'll store 1 as repeated one time, 2 has repeated 0 time, 3 has repeated also 0 time. So this can be considered as a subarray. Yes, it can be considered. What will be its length? Length will be just 1, correct. Now let's try to increase the subarray length. So now we'll consider this subarray, okay. So many of you may have doubt in what subarray is. Subarray is nothing but a contiguous set of elements. So like if I want to count any subarray, I will count all the elements in the order, okay. So here 1 2 3 is a subarray. If I'll say 1 and 3 is a subarray, no, it is not. It is a subsequence or a subset, okay. So subarray, there is only one and one condition, that the elements ordered should be maintained. Elements order should be maintained, okay. So let's now consider 1 and 2. This is a subarray. Here what is the frequency of 1? Again 1. Frequency of 2 is 1. Frequency of 3 again 0. But here length has increased from 1 to 2. Now similarly coming here to this subarray. So I think the answer is ready with all of you guys. This will be the frequency of each element and the length will be 3. Let's just abbreviate length as L, okay. Yep. Next, now in this subarray, how much the frequency of 1 is? It's 2. 2 is acceptable? Yes. Okay, sorry, I think I didn't give the value of 2. So here 2 is, here k is equal to 2. So I have to find the maximum length of the subarray in which frequency of each element is less than equal to 2, okay. So 1 is repeating as 2 times. I am considering this subarray, by the way, okay. So if you see, 1 is repeating as 2 times, 2 is repeating once, and 3 is repeating once. So 2 repeating 1, 3 repeating once. What is the length? If you check, it is 4, exactly 4, okay. Now coming ahead, now if you select this particular subarray, here you will get one frequency as 2. Let me highlight the subarray again. This is the subarray which I am talking about, okay. So 1 is repeated 2 times, 2 is also repeated 2 times, 3 is repeated once, okay. So 1 is repeated 2 times, 2 is also repeated 2 times, 3 is repeated as 1. L will be what? 5. You can check. The length is again 5 from here to here. 1, 2, 3, 4, 5. Correct? So we are going better till here now. Now let's select this whole array. Okay, this whole subarray we have selected. Now here exactly the elements frequency is 2 for each element. For 1 it is also 2, 2 it is 2, 3 it is also 2. Length will be 6. Okay, good. So till now here we have got it. Now when we will try to extend this subarray, we'll get that 1 is repeating 3 times, which is not acceptable. So I think we have to exclude this one and we have to start from the next index. We have to start selecting the subarray from the next index. So now if we will select from this index, from first index or from 2 element, so till where we can go? Till here we can go, right? Earlier this one was not getting included because of this one, but now we have excluded this one, so we can include this one, correct? So if we select this subarray, again I have 2 2s, 2 3s and 2 1s. Again the condition is satisfied, right? So let us write the subarrays now which are possible. So one is 1 2 3, 1 2 3. Another one is 2 3 1, 2 3 1. Yes, this one, correct? Another array, yes it is. There is one more, I think. What about this subarray? It has also exactly 2 frequency of each element, 1 2, 1 2 and 1 2. So there is one more subarray which we found, which is 3 1 2 3 1 2. Now you found these subarrays as well, correct? Of 1 length, 2 length, 3 length, 4 length, 5 length, 6 length. So what is the maximum length you were able to achieve here? 6, right? See, here 6 length is the maximum length and here the condition is verified. Similarly for this subarray, again the length is 6. Again for this subarray the length is 6. So that is clear that the maximum length of the subarray in which each element has a frequency less than equal to k is equal to 6 for this case. Okay, so I can write my answer as 6. So now how we will design an approach to this problem. So whenever any problem comes related to frequency, then we have 2 approaches. Okay, we have 2 approaches. Basically we have to store the frequency, that is one thing. But how we can store the frequency? We can store the frequency in 2 ways, either by using frequency array, or the second thing is by using hash map. Okay, now using frequency array, it's a good thing, but when our constraints are high, so like the problem constraints are nothing, but if you can see the coding screen, you can see the constraints here. Nums dot length is from 1 to 10 to the power 5. Nums I can range between 1 to 10 to the power 9. Okay, so if you will create a frequency array, each index will mark the frequency for each element in the array. And now if you can see, there are exactly the highest element possible in the array is 10 to the power 9. So we will have to create a frequency array of highest 10 to the power 9, exactly 10 to the power 9 plus 1 to be very exact. Why? Because the last index will be 10 to the power 9, and as array is 0 index space, so this should be the length exactly. And you cannot make length like this much length array in any language, so better to use hash map in this case. Okay, hash map actually works on the principle of hashing. You can see its implementation in any of the docs, and I think each and every language has support of this particular structure. So we'll use hash map in this. Okay, so first thing is clear that to calculate frequency we need to have some particular structure, and that we will use as hash map. Okay, now let's try to create an approach. Okay, approach to solve the problem. Okay, so one thing is clear that we need to calculate the frequencies, correct, and we need to find the maximum length in which the frequency of each element is maintained, right? Okay, so let us just check one more example, and I think that example will make you more clear about the problem. So I have this particular example as 1 2 3 1 1 2, then I have 5 3 3 1 1 2, and then I have 5 2 3. Just creating the index so we don't face any problem while creating our approach. So this is a 14 index, which means the length of the array is 15. Now let's try to catch the frequency in a hash map. So hash map is just like a key value pair kind of structure which stores the key and the corresponding value. So here the key will be element and the corresponding value will be its frequency. Okay, so element and frequency. So now coming ahead, so 1 is coming, correct, 1 is there. So let's define first 3 variables. Okay, now we need to find the length of the subarray. So we need to find the starting point and the ending point of the subarray. So for that we'll use start and end. Okay, and there will be a max length variable as well. So we will put length and max length. Okay, so start will be initialized with 0. Wait, let us do it in the other manner. Let end be equal to 0. Okay, and start be equal to -1. Why -1? Because currently we are starting from the first element itself, and we are thinking that our maximum possible array can include the first index or the 0th index as well. That's why we are not excluding it. That's why our start is -1. Okay, let's check. So for 1, when I am here exactly at 0 index, 1 frequency is 1. So here 1 frequency is exactly 1. Then it will go to 2, right? So it will go to 2. 2's frequency is exactly 1. Then it will go to 3. 3 frequency is exactly 1. Then it will go to 1 again. So now when it went to 1, okay, so let me tell you that my end is increasing. Okay, so when I calculated the frequency of 1, my end was 0. Then my end straight away went up to 1. Okay, it found 2, it increased the frequency of 2. Then end increased to 2, it found it 3, it increased the frequency of 3. Okay, then I went to 3, third index, again I found 1. So now 1's frequency will be increased to 2. So when 1's frequency is increased to 2, tell me, is it okay? Okay, sorry, I have again forgot to give the value of k. So here again k is equal to 2. Okay, so we have to find the length of the longest subarray where each element has a frequency less than equal to 2. So currently I think all the 3 elements have frequency less than equal to 2. So I think this particular length can be accepted till now. What is this particular length? If you count 1, if you count it 1 2 3 4, 4 is the length. So my length will be 4, correct, my max length will be 4. Okay, we will calculate length at each and every step, but since I was like trying to count the frequency in the hash table. I just forgot to actually update the length and max length variables at the same time. So coming ahead, so my end is now 3. Okay, end is now 3, one frequency is turned to 2. Now at when my end will become 4, now the thing is there to note. Now exactly at this index, my ones frequency will change to 3. Is it acceptable? No, it's not. We have strictly defined our KS2 and we need all elements frequency less than 2. So what we will do? Now our start index will come into picture. Now start will say that okay, I will try to shrink my window or try to shrink my elements from the left. Okay, from the left. So now we'll do start plus plus. So start will be pointing to 0 now. And when started to point here, we will make sure that we decrease the frequency of the element which is pointing to start. So start is pointing to 1, we will decrease the frequency of 1. It will be 2. Okay. So now tell me what will be the length. Length will be exactly end minus start. What is the end? 4. What is the start? 0. So 4 minus 0, 0. And if you check right now, let me erase this. Okay, start is now pointing. Now this is not into the picture, this element is not there. So if you see, this is the length which is there now. It is exactly 4. Yes, it is. Okay, now coming ahead, we'll go to 5th index. So 5th index is 2. So we'll mark the frequency of 2 as 2. Okay, now after that we went to 6th index. So 6th index is 5. It's a new element. We'll add it. So 5 frequency is set to 1. Now we went to 7th element. Okay, 7th. Now end is at 7. Now 3 is again there, right? So we can update the frequency of 3 to 2. No issues. Okay. Yeah, start is here only. End has become here. So now my length would have also been increased, right? I'm not updating it. Yes. So I have to update it as well. Okay, so now my end is 7 and my start is at 0. So I'm saying that till this array I can have all the elements because each and every element has the frequency less than equal to 2. You can check in this. 2's frequency is less than equal to 2. Yes. 3's frequency is less than equal to 2. Yes. 1 frequency is less than equal to 2. Yes. 5 frequency is less than equal to 2. Yes. So what will be the length in this case? So length will be nothing but end minus start. End minus start, which will be 7. And this will be the maximum length, correct? Because earlier it was 4. We increased to 5, then 6, then 7, correct? Now we are at 7th index. Now we will go to 8th index. Now when we went to 8th index, what we found? We increased our frequency of 3 to 3. Okay, I think it's we increase the frequency of 3 to 3. Okay, don't get confused. So now what we will do, we will start increasing our start pointer, okay, until we find the element which has increased frequency, okay, which has increased frequency, so that we can decrease it. Okay, let's do it. So I'll increase my start value by +1. Now when I did +1, so I'm saying that I'm excluding this element, so 2 will be excluded. Although 2 is only repeating 2 times here, but I have to exclude it. Why? Because subarray is a property. Subarray is a property that all the elements should be in an order. Okay, so if I am moving my start forward and till now the frequency of 3 has not decreased, so I have to sacrifice 2. Okay, so I have to decrease the frequency of 2 from 2 to 1. Sorry, yes, so 2 to 1 it has been decreased. Now start has become 1. Okay, now going ahead, Now when we went ahead, start went here. Okay, now start is at 2. Okay, now here exactly 3 has came. Okay, now we can delete the frequency of 3. So we can reduce the frequency of 3 by 1 and it will again be 2. So now what I am saying, that I have excluded these two elements, and now from 2 to 8, now from 2 to 8, not including 2, okay, from 2 to 8 I have another subarray which has at most 2 frequency of each element. You can check it. 2 for 1, okay, 2 frequency for 1, 1 frequency for 2, 1 frequency for 5, and 2 frequency for 3. Even if you want to verify, you can verify here as well. 1 is repeating 2 times, 2 is repeating only 1 times, 3 is repeating 2 times, and 5 is repeating only 1 times. So what we are doing, we are actually in the runtime itself, we are updating the frequency of each and every element, right? We are making sure that if any element frequency crosses k, then we have to move our window, or we have to shrink our window. Okay, we have to move the start pointer, and we have to delete or reduce the frequency of the element which we passed at start pointer, right, or which we reached at the start point. Okay, so basically we reduce the frequency of 3 because we reached there, right? Okay, coming next. Now everything is fine, we'll go to 9. Now again, if I go to 9, right, what will happen? Again the frequency of 1 will be increasing to 3. So now again I have to make my start active. I have to make sure that I have to make it forward. So I will move it forward, and when it will move forward, it will say, oh, I found 1. Now I will decrease the frequency of 1. Now it will be decreased to 2. Okay, and we will remove this 1. Okay, now so from 9 to 2, what is the maximum length right now? 7 only. 9 minus 2 is 7, correct? What is the array? Basically it is from, okay, I think, okay, so we have yes, sorry, so we have increased our start now, so it has become 3. So 9 minus 3 is 6. So if you see, not including 3, fill 4 to 9, I'm getting another subarray which is in which every element has having less frequency than 2. Okay, you can check. 1 is exactly repeating 2 times, 2 is exactly repeating 1 time, 5 is exactly repeating 1 time, 3 is exactly repeating 2 times. You can check here. 2 is exactly repeating once, 3 is exactly repeating twice, 5 is exactly repeating once, and 1 is exactly repeating twice. Okay, now we will go to 10th index. Okay, let me just create a space here. Okay, so now we'll go to 10th index. Now 10th index is there. Now again the frequency will increase to 3. Again I have to move my start pointer, so my start pointer will move again. Okay, start pointer has moved again. Now this will remove, correct? So start pointer has came to 4. So again I have to decrease its frequency from 1 to 2, because the start pointer element's frequency should be decreased from the hash map. Now from 4 to 10 means from exactly 5 to 10 I have another subarray. Okay, and its length is 6. It's less than 7, which we find earlier, right? Okay, so till now maximum length is this. Now let's move to 11. So 11 index, 2 is there, so 2's frequency will be changed to 2. Everything is fine, correct? What is the length now? 7. Length is 7. We can't, max length is again 7, so no problem at all. Now we'll again move to 12. Now 12 is what? 5. Now exactly at this point we will change the maximum length. Why? Because now I have found an array between 5 to 12, right? Both inclusive, right? 4 is the starting, we are not including the starting, I told you earlier. So from 5 to 12, we have this subarray of 8 size, end minus start. What is it? 8. So now exactly we got 8 here, and our max length is updated from 7 to 8. Okay, so this is the maximum length. Now we'll go here again, 13th index. Again 2 came. Now I have to move my start index. Okay, I have to move my start index. Now start index will be moved here exactly, and this will be removed. Okay, and its frequency will be, it was 3 but it came down to 2. Okay, so now my start is pointing at which position? 5 position. Okay, now what is the length exactly? 13 minus 5, which is again 8. No need to change. Okay, again I have my next pointer is 14. Okay, and 14 is the last pointer. So 14, I increase the length of 3. This is can't be possible, so I have to move my start. So when I'll move my start, right, I will face 5. So I have to decrease the frequency of 5 by 1. Okay, so its frequency will decrease. Now again I have to go ahead because I did not change the frequency of 3 till now. So this will be pointing to 3. Now I have to decrease the frequency of what? 3. So 3's frequency will be reduced to 2, and thus from, now my start index came from 5 to exactly 7, and my last index is at 14. So again the length which is there, it is 7, which will not replace 8. Okay, so my maximum answer is 8. Okay, so did you find the whole try run interesting? Let me know in the comments. Okay, and let's just try to code this now. Okay, so I'll shift back to my IDE screen. Okay, and we'll try to write this approach. Okay, so yeah, I think we are there. Yes, we are. So first thing is, we will take int n is equal to nums.size. Okay, nums.size. So nums is a vector. It is an STL, standard template library, which gives us support of many functions, right? Inbuilt functions, which makes our life easier. But you can consider vector as completely similar to array. It's completely similar to array. It's nothing different. Okay, so now I have to create int start, which is my -1. I have to create int end, which is 0. Okay, now I have to start my end. So as I have declared it already, right, so I can just write this. Okay, I am doing n++. Okay, good. Now one thing which we forgot is to add the map. Okay, see, unordered map, these are different identifiers. Unordered map means that the elements will not be in a certain order. If I will use only map, then the keys will be arranged in an ascending order. Okay, that is the only difference. So end is 0, end is less than equal to n, and end is less than n, we're going to the end. Okay, so frequency nums of end, which will be ++. So what this will do, it will increase the frequency of each element at its key position. Okay, so nums end will be containing 1, correct? So it will increase the frequency of 1 ++. The value is there. So actually it is very simple implementation of hashmap in C++, but in other languages you actually need to find the key first. If the key is present, then you can simply increase the value by doing this, or otherwise you need to insert a new value. Okay, basically in Java there is a difference. Okay, but in C++ you can do this, it will never give an error. Now suppose my frequency of nums end got greater than 2, which we saw in my in the dry run as well, that for 1 or for 2 the frequency was getting increased by 1. So we made sure that we increase our start plus plus, and we make sure that we decrease the frequency of the element to which start is pointing, no matter what the element is. Okay, now we will have an int length which will be nothing but end minus start. Okay, and we will have an int max length, so I have to make int max length outside. Okay, next max length will be nothing but max length comma max length. Okay, so this step is doing exactly what we did. Whenever any element's frequency was getting increased or was getting greater than k, we were making sure that we are moving our start pointer ahead, and we are decreasing the frequency of those elements to which start pointer is actually pointing. Okay, so that's all I think. Let's check that if there are any compilation errors or something, any declaration which is left. I don't think so. I have to just return max length here. I didn't find any such errors till now, but still, let's see if it runs fine or not. Yeah, it ran fine. All the cases are passing. Let's just submit it. Yeah, so you can see it actually beat the solution of 73% users, and it also took some memory, right? So the time complexity for this solution is O of n. Why? Because as you saw in my dry run, right? Or I will shift to my iPad screen. Okay. So if you see, we are visiting any element at most twice, not more than that, right? If our start is here, right, we first approached all these elements with the help of end pointer, and then when we found that okay, this particular frequency is not reaching greater than k, then we make sure that okay, we will move our start pointers. So any element will be at most touched twice. Okay, so if we take a worst case also, that each element in the array has been touched twice, so what will be the total number of iterations? It will be 2 into n, right? Which will be nothing but O of n. Okay, we will ignore the constant. So the time complexity for this is nothing but O of n, and space complexity, as we are using a hash map here, so it will be O of n. Okay, so yeah, so I think that was all for this solution. Thank you so much. If you love this solution, like this video, and I will be posting other solutions as well for other Leetcode problems, so do subscribe to my channel. Thank you.